Okay, and very good evening, everyone. This is Paul N0T from the Front Range 6-meter group. And tonight we've got Carl, K9LA, to give us a great presentation and discussion on propagation and some of the neat things that are happening today. So Carl, with that, I'm going to throw the speaker over to you.
Okay. Let me take a couple things. Well, good evening to everyone, and it's good to see everybody. I think this is the first time I've ever met Jim, K6MIO, in person. We've emailed, have emailed exchanges, but I don't think I've ever met him personally. So it's good to see him, and hope he's enjoying stroke 4 instead of stroke K6. And Paul, thank you for inviting me. And what I'm going to talk about is, let's see here, share screen, 6 meters, and I'm focusing on F2 region propagation. It can only do so much in about 45 minutes. So I thought I'd focus on that, although I'll have a little bit to say about some other topics. Let me close some other stuff here. Okay, it's up on my screen, and it should be full screen here in a little bit. It even says participants can now see my application. How about that? There we go. It's going full screen for me. Hey, it worked. So, like I said, good evening. I'm Carl, K9LA, from Fort Wayne, Indiana. We're quite a bit west in the Eastern time zone, but we're still in the Eastern time zone. So it's 9 o'clock here, so that's not too bad. So one of the first things I thought I'd just mention is my experiences on 6 meters. I'm probably not as hardcore as many of you. I do casual contesting, mostly ARRL June VHF contest, which is this weekend. And I'm going to do a single op low power CW. And I hope to work you. Casual DXing, I work Europe, Caribbean, South America, JA, but I really haven't gone after some of the more exotic stuff. I do a lot of reading to try to better understand F2 propagation and also sporadic E, especially on 6 meters. Unfortunately, I'm not doing too much of the above so far this year due to other priorities. So, oh well. So we're going to talk about a quick review of the F2 region, 6 meter propagation predictions in relation to the F2 region. Very quick update on cycle 25, look at some data. And trying to determine the QSO you just made, is it sporadic E or F2? We'll go through some discussion about that. And then a potpourri of several other topics, one being the JE1 BMJs, short path, summer solstice propagation, SSSP. So there are a heck of a lot of modes on 6 meters. Some are require lots of effort, some probably are very low probability, but can be done. What I'm going to talk about is the F2 hops and also transequatorial propagation, those 2 items circled in green, and also, well, shoot, when I enlarge the screen, the circle around SSSP moved, but it's supposed to be around SSSP. So I don't know why the other one didn't move, but we'll talk about those things. Okay. So there's an electron density profile of the ionosphere. And of course, the F2 region is the highest region. And what that means is the F2 region gives the longest hops. But the F2 region has the smallest M factor. What's the M factor? That's the factor by which the critical frequency of the ionospheric region is multiplied by to get the MUF, we'll go through an example of that. So here's a crude picture of the E region and also the F2 region above the Earth. The hop for the E region, maximum of about 2,000 kilometers. And that's the line going up and then the red line coming down. And the maximum F2 region distance depends on frequency. And why is that? Well, that's because the lower the frequency, the more the refraction. And what that means is the wave doesn't get as high into the ionosphere. So it's a shorter hop. You can see the F2 region goes up all the way up to the array goes all the way up to the F2 region and back down to RX2. So if you do ray traces, and I did that at 2-degree elevation angle using PropLab Pro version 3, which is Windows. This is at high solar activity around noon local time for the path I set up, a single hop path. Now there's a way at the top there, there's a 49 megahertz trace. Again, that's launched at 2-degree elevation angle. It's pretty low. And you can see it goes out to something like 4,600 kilometers. Actually, if we were able to launch it at 0 degrees, it'd go out to about 5,000 kilometers. The 28 megahertz difference or distance you can see there ends up at about 3,600 at 2 degrees. At 0 degrees, it'll go about 4,000 kilometers. And as you can see, as you go down lower in frequency, the ray doesn't get as high into the ionosphere, and generally it ends up a shorter hop. And you can also see that refraction occurs. It's very obvious. It takes a while to bend, especially a 6-meter wave. And the vertical extent of the bending is on the order of, looks like about 20 kilometers. So what that tells us is sporadic E, the layer only being, a couple kilometers thick is likely a reflection because of the very high electron density in the sporadic E region. Okay, we'll get back to the M factor. There's some angles labeled on that plot. There's A, which is the launched elevation angle. Then there's B, the elevation angle, the angle of incidence between the ray and the E region. And C is the angle of incidence between the ray and the F2 region. Now, if we were looking at a planar Earth ionosphere, in other words, a flat Earth and a flat ionosphere, A would be equal to B, which would be equal to C. But since we're dealing in spherical coordinates, A does not equal B. So for example, if you launch a 0 degree elevation angle, the angle of incidence on the E region is about 10 degrees. That's the lowest it gets. Similarly, if you launch a 0 degree elevation angle from the ground, the lowest it gets on the F2 region at a typical height of 300 kilometers is about 17 degrees. So the M factor is 1 over the sine of B for the E region and 1 over the sine of C for the F2 region. And you can see that if the angle is bigger, the sine is bigger, but 1 over sine is smaller. So the M factor is smaller. So what that says is if you have data of the critical frequency of the ionosphere, like for example, the E region, if the critical frequency is 3 megahertz, the M factor is roughly around 5. So that means the MUF would be 15 megahertz. If you have an F2 region critical frequency of 8 megahertz, The M factor is at the low elevation angles is around 3. So that says the MUF is going to be 24 megahertz. It's some simple spherical math shows all of that. Now let's take a look at Denver to the United Kingdom at 1500 UTC. And that's on mid-October. I don't know if you can see, there's a green path going from Denver to the United Kingdom. It's not very, it could be a lot thicker, that's for sure. It's a 39 kilometer path, 7,639 kilometers. And it's, the path is all in daylight. Now, if we take a look at a world map of maximum usable frequencies at 1500 Zulu in October 15th, that's what we'll get. Now that green line is on there going from Denver to the UK, and to make it more visible, the UK is the yellow X, Denver is the yellow X, and the yellow X is also the UK location on the other end of the path. The violet X in between assumes that it's 2 hops, and that's where the ground reflection would be. The 2 red X's are where the ray would encounter the F2 region of the ionosphere. And what you can look at is, you can see the MUFs up around, probably around 29, 30 megahertz. Now, what's kind of obvious is during daylight, paths to the east-west paths pretty much have the same MUF, okay? As you see, the similar contour lines go from North America over to Europe and everything. And they're about, so a path is kind of following the same contour line, or pretty close. Now, contrast that with going south, or even southeast out of Denver, the MUF is increasing. And that's why, north-south paths are more dominant until we get enough sunspots to keep the east-west path going. Now, the October 15th, this was done at a smooth sunspot number similar to cycle 21 and 2022, which was pretty much bigger, two big solar cycles. It wasn't as big as cycle 19, but they certainly were good enough to give lots of good 6-meter propagation. It's too bad we didn't have more 6-meter rigs back then. Cycle 21 peaked in 79. Cycle 22 peaked in about 89. So let's take a look at a Caribbean to deep Argentina, 2200 Zulu. And this is under October 15th, again at the moderately big solar cycle. You can see the path is from the Caribbean all the way down to the southern tip of Argentina. And what does the MUF, the worldwide MUF, look like for that path? That path is also the green line, and the 2 yellow X's are the Caribbean end and the deep LU end. And if you look at the contour lines, you'll see that the path coming out of the Caribbean encounters some pretty high electron densities. Then there's a dip in the electron density, and that's the magnetic equator. And then there's another high electron density a little bit farther south before getting into the deep LU. So that is the signature of transequatorial propagation. There's a side view. The previous slide was looking at a view from overhead. You can see that there's some clumps of high electron density on either side of the magnetic equator, about 10 to 15 degrees either side. And then there's a dip in the middle, and the red shows what a ray does for transequatorial propagation. It goes up to that high electron density on the left side. It's not refracted back to Earth. It's just refracted enough to kind of parallel the Earth until it gets to the other high electron density, and then comes back down into LU. So that's a very telltale signature of transequatorial propagation. At the appropriate time of day, transequatorial propagation happens all around the world at all longitudes. But of course, you need some hams on the other end. Here's some common transequatorial propagation paths. I'm sure you're probably aware of them. There's like the Caribbean down to deep LU. We kind of looked at that. There's one Caribbean into ZD8. That was an interesting one. That's because the magnetic equator takes a dip over South America and then kind of comes back up to the northeast. And you can see those paths are generally perpendicular to the magnetic equator, which is the dashed line, the dashed wavy black line. Of course, Southern Europe to ZS6 and JA to Northern Australia. What's interesting is the blue one, well, it's purple, I believe. That's XE3 Kilo Echo to LU6DO. That was in August 1947. And that's what led to the discovery of transequatorial propagation by hams. So, we claim transequatorial propagation and what happened. Now, what's kind of obvious, though, for most of us in North America, we need a link to transequatorial propagation. And it's either a sporadic E-link to get close enough, or it could be a normal F2 hop. So we need some help, but we've had some transequatorial propagation already. And I'm sure we'll have more as cycle 25 gets higher. Okay, some predictions. Earlier this year, John in 0JK reported a March 21 QSO between PV8DX in northern Brazil and Florida stations, and some other too, up a little bit farther north. And that's the red line. They were sideband contacts around 1845 UTC, and it's about a 4,000 kilometer path to Florida. Now, that is not a typical transequatorial path. A typical transequatorial path is the green path there from the Caribbean down to LU. And even the midpoint of the red line, the midpoint of the PV8DX to Florida path, is even farther north than the northern crest of the equatorial ionosphere. So it doesn't look like any transequatorial propagation mechanism took place. It was strictly F2, normal F2, I guess you'd call it. Also on that map is the Ramey in Puerto Rico ionoson. It's located about midpoint of that red path. It's not exactly on the red path, but darn, it's pretty close. And it reported the F2 region MUF was greater than 50 megahertz. So it just so happened that was a good day for the F2 region in the Caribbean. And it allowed normal F2 propagation to happen. So what forms the F2 region? Well, it's the extreme ultraviolet radiation, which generally is from 10 to 100 nanometers. That's pretty short. And that EUV ionizes atomic oxygen. Interestingly, about 60% of the F2 region is due to radiation from 26 to 34 nanometers. And I just mentioned that because the N0NBH banner that you see at QRZ.com and other places reports the 30.4 nanometer radiation. It's called 304A, which is 304 angstroms. So that might be something to look at in addition to solar flux. Now, those white areas around sunspots, those are plage, which is French for beach. It's kind of like a white beach, and those are the areas that emit EUV, lots of EUV. So sunspots themselves have nothing to do with propagation, just as solar flux has nothing to do with propagation, because the energy of 10.7 centimeters solar flux is way too low to ionize anything. But it's a, solar flux and sunspots are a proxy for EUV in the F2 region. So let's take a look at how the MUF varies versus a solar cycle. And I'm looking at the Denver to UK path in October at 1500 UTC. And I've assumed it's 2 hops, 7640 kilometers. So each hop is about 3820 kilometers, not unreasonable on 6 meters. It requires kind of a low angle, but the height of 6 meter beams can be very good in terms of wavelengths, because the wavelength of 6 meters is only about 20 feet, something like that. So here's the data. It goes from a smooth sunspot number of 0 all the way up to about 280. The smooth sunspot number of 280 would be an equivalent to cycle 19, way back in 1957. And you can see what the monthly median MUF does. It goes from a low of about 22.5 megahertz all the way up to about 42 megahertz. Now you got to remember our propagation predictions, regardless if you use VOACAP or W6EL-prop or whatever else, the results are monthly medians. That's because the model of the ionosphere in these programs is a monthly median model. So on any given day, the actual MUF could be 15% higher to 25% lower. So that 42 megahertz on a good day could be in the high 40s. Now, why is this? Well, that's because our understanding of the ionosphere is not complete yet. We know that solar radiation causes the ionization to vary. We know that geomagnetic field activity causes the ionization to vary. But there's something we're missing, and that's the events at ground level and in the troposphere and some other events that can modify the F2 region of the ionosphere. And since we don't have that in the model, that's why we don't have daily predictions. We have monthly median predictions, and they're statistical in nature over a month's time frame. How about MUF versus month? So here's the same path, the high sunspot number, and that's at 1500 UTC. And this is the MUF versus the month. And you can see it's very obvious that the fall and winter months are best for northern hemisphere contacts. And it's also obvious that the summer months are the worst in this northern hemisphere for QSOs. Now, it's also pretty interesting that CQ Worldwide DX contests are end of October and end of November. So they pick the right time. I've tried to dig out why they ended up there, but I haven't had that much luck. In fact, when they first started, they weren't even at the end of October and the end of November. So something happened, and I've not been able to find out why, but they sure picked a good place to have contests. And of course, you have to remember in the Northern Hemisphere, that's where the three major ham populations are, Japan, North America, and also Europe and Asia, a lot of Asia. Okay, what about the diurnal variation of the MUF? Well, here's the same path, and here's what happens throughout the day. And it's kind of obvious that at least in October, probably it's going to be kind of similar. The best time from Denver to G via the F2 region, remember we're talking about the F2 region, we're not talking about sporadic E or anything, is late morning local time. So that's something to remember. So just a quick summary of all the best times. 2 other stations in the Northern Hemisphere. Well, it's at the maximum of the solar cycle. Even though cycle 24 was kind of small, smallest in our lifetimes and the 4th smallest in recorded history, we still had some 6-meter F2 propagation at the maximum of the solar cycle. And it was around the fall and winter months. Of course, don't forget about sporadic E in the summer. And for you guys to Europe, it's most beneficial in the late morning, most likely, and to JA's late afternoon. That's for F2 region propagation. Now, what if you want to talk to people in the Southern Hemisphere? So I took the plot for the Northern Hemisphere, which is blue, and just put the curve 6 months out of phase for the Southern Hemisphere. And what you can see is that around the equinoxes is probably the best time, because the MUFs are kind of equal. You don't have one way up and the other way down. So just something to remember. Okay, cycle 25 progress. Well, here's the latest data. It's includes the May data, which says the latest smooth sunspot number data is for November 2021. Remember, because the smooth sunspot number heavily averages 12 monthly means, that it's 6 months behind the monthly mean, which the latest data is May 2022. Now, the red is cycle 25. The green plot is cycle 24, which, like I said, was the smallest in our lifetimes and the 4th smallest in recorded history. Orange is the average, an average cycle, kind of like cycle 23 was average. And the blue is a moderately big solar cycle, like cycle 21, which peaked in 1979. So you can see where cycle 25 is right now. And I get the question is, is it going to be similar to, is it going to slow down and be similar to cycle 24? Is it going to keep going up and be similar to cycle 23, or maybe somewhere in between, or something else? I would think that since we're about halfway up cycle 25, that we should know pretty much what's going on in the next 6, maybe 6 to 12 months. So we're just going to have to keep collecting data and see what happens. And that'll be interesting if we don't have 2 peaks. That'll suggest that the red line is going to do good, especially for a 6-meter propagation. Now, here's something we talked about a little bit before. This comes from the URL in the title. By the way, Paul, I'll send a PDF of these slides. This is from July 5th, 2021 to June 6th, 2022. And it shows the daily 10.7 centimeters solar flux in black, the daily sunspot number in red, and the daily AP index in blue. And you can see way on the left, we were kind of just coming out of solar minimum. And you can see there weren't heck of a lot of spikes. But as we move to the right, as cycle 25 gets bigger and bigger, we see a heck of a lot more spikes. And you can see way at the right, we just went through a nice big spike in the solar flux and the sunspot number. Now we're kind of down in the doldrums again, but it'll come back up. And the result will be cycle 25 is increasing even more. So it might be good to take a look at this and see where we are. And you might be surprised if you have, you might be surprised if there could be some good enhancements for 6-meter propagation. Okay, one of the good questions is, was that QSO sporadic E or F2? And had to think about this a lot. What you can look at is, of course, look at the path distance. If it's a short path, a couple thousand kilometers, more than likely it's sporadic E, because for it to be F2, you'd need to refract some pretty high elevation angles. And the ionosphere typically isn't that strong to do that. Coming up on slide 39 is, I think there are 5 documents from Jim, K6IMO. I have them listed. And why I did that, because longer paths can get very complicated. It may not just be multiple sporadic E hops or multiple F2 hops. It could be combinations. It could be maybe some chordal hops, maybe some ducting. And I believe Jim talks a lot about that in some of those documents. So take a look at those. I think all you have to do is Google K6IMO, and I think it'll come up. Jim can add at the end here if that's true or not. Of course, where we are in a solar cycle, if we're around solar minimum, more than likely it's going to be a sporadic E contact. What month? Well, if it happens in the summer month, it's pretty much a sporadic E. If it happens outside a summer month and maybe not in December, then it could be F2. The time of day, the patterns of sporadic E throughout the day is different than the pattern of the F2 region throughout the day. And what we're going to look at is an example on the next page, on the next slide. So in the summer of 2005, June 23rd to July 2nd, that was about halfway between the cycle 23 peak and solar minimum. So we're about halfway down cycle 23 solar cycle. J68AS in St. Lucia made 380 QSOs with Europe on 6 meters. Was this ES or F2? The general consensus from a lot of people was it was 4 sporadic E hops. So here are the QSOs versus time. And of course, that is a probability distribution. So let's compare to ES probability versus time and F2 region probability versus time, and maybe see if one is more likely than the other. So how do you look at ES probability? Well, you go back to this old figure there on the left. It's 2 years of data. It shows the months on the horizontal axis and the local time on the vertical axis, and those contour lines are probabilities. Now I've shaded green the highest probabilities, and you can see in the summer months, May, June, July, August, late morning and early evening gives the best probability of sporadic E. There's some probability in December, like we typically know. And the second year did the same thing. There's a little bit of difference, but still the general trend is the same. So what you can do is break the path into 4 hops to see if the hypothesis that it was 4 sporadic E hops was good. And by doing that, you can calculate the local time in each of the 4 hops and use those probabilities. And that's what that red line is, the probability of 4 sporadic E hops, and it just doesn't look right. The probability of ES was lowest when the most QSOs were made. So maybe 4 ES hops wasn't what happened. And that leads one to look at, well, let's look at the F2 region. Now, J68S is at 14 degrees latitude, north latitude. I should have had that. Now let's assume it was an F2 hop out of J68AS because you're kind of close to the equatorial ionosphere, which is the most robust portion of the ionosphere. But as you go even farther north towards Europe, the F2 maximum usable frequencies are decreasing because they decrease heading for the polar areas. So let's assume that the last 2 hops were ES. So let's look at the probability of an F2 hop and then an ES hop and another ES hop. And if we go work through all that, which was quite a job, but it was interesting. The green line is that probability, and it seems to peak about the same time as the QSOs peaked. So that looks like a possibility that it was an F2 ES mode, which again shows you that things can get quite complicated up there in the ionosphere. Okay, some other topics. A while back, JE1BMJ had an article in the 6 News about short path summer solstice propagation, SSSP. And what he invoked was there's refraction from polar mesosphere summer echoes, PMSE. And PMSE are radar echoes from about 80 to 90 kilometers below the E region, in fact, the E layer, from mid-May through mid-August in the Arctic. And that's what that chart at the bottom shows. It shows when the echoes were most prevalent from the radar. And it's kind of identical to a sporadic E, so that could make it tough to, was it what JE1BMJ is suggesting, or was it just typically sporadic E? Well, if you look at Denver to JA, the maximum latitude the path gets to is about 55 degrees north. So maybe Denver to JA is more slanted towards sporadic E. But if you're W1 to JA, the max latitude is about 73 degrees north. And that's more likely that it could be polar mesosphere summer echoes. Now, can polar mesosphere summer echoes support 50 megahertz? Well, yeah, there was an interesting paper back in 2019, and they measured electron densities of the polar mesosphere summer echoes. And that's what the chart on the right is. And the color code tells you the electron density, and the PMSE are those reddish pinkish returns. Now the critical frequency based on 1e to the 12th electrons per meter cubed is about 9 megahertz. Then that's the critical frequency. Now, remember that M factor? Well, the M factor for low elevation angles at a layer around 85 kilometers is around 6. So 6 times 9 is about 54 megahertz. So that says PMSE can support 6 meters. I'm not sure how we'd ever tell the difference if it was sporadic E or PMSE, or if there were some other combination of modes, ducting or quartal hop or anything like that. All we can do is kind of gather data and see maybe if something fits a pattern of PMSE or ES the best. What about the digital modes? Well, FT8 has taken over ham radio, that's for sure. If you look at club log each week, you can see that FT8 is, is more than all the other modes combined. CW sideband, FT4, everything else. Of course, the DX contests, ARRL and CQ, result in peaks in sideband and CW, but still FT8 is taken over. And those are the signal to noise limits given in the WSJTX documentation. They're all referenced to a 2500 hertz bandwidth, so you can directly compare what's going on. And you can see that FT8 has about a 6 dB advantage over CW per that table. Now, there's an assumption in that CW, that's a human ear brain interface. That minus 15 dB SN limit in 2500 hertz translates to a minus 8 dB signal noise ratio in 500 hertz. That, to me, seems like a pretty good operator. So that led me to test what I could hear. And I could hear a signal about 2 dB below the noise in a 500 hertz bandwidth. So not sure what to say. I don't know if that CW ear to brain of minus 15 dB and 2500 hertz is typical, or maybe it's for a really good operator. But regardless, FT8 still beats it. And of course, Whisper leads the pack for the best decode probabilities. So how does FT8 help 6 meters? Well, when I went to full screen, the chart lays over some of the text. I'll have to look at that. If there's enough ionization for refraction, then FT8 can decode a signal at a 6 dB farther down. And that could be into the noise. You won't hear it on CW. And you probably wouldn't hear it on sideband, but the FT8 could still decode it. And those little figures show that, what happens if the operating frequency is less than the MUF for pure refraction. And if the operator frequency is greater than the MUF, what happens? It goes up into space, never to return. But there's another scenario. Can there be some wiggle room to allow the operating frequency to be a bit above the MUF, but at the expense of some extra loss? That sketch there on the left kind of shows, maybe something happens that's kind of ionospheric scatter. There could be side scatter, ground scatter, who knows? But VOACAP, interestingly, has an above the MUF algorithm in it, which, and depending on how much above the MUF is, it adds extra loss. And if you're not, too far above, the loss is not too prohibitive. And you have to also remember that ionospheric absorption at 50 megahertz is pretty minimal, because absorption is inversely proportional to the square of the frequency. The higher in frequency you go, the less absorption. In fact, a 1-hop 6 meter path has about 1 dB of absorption per ray tracing with PropLab Pro V3. Kind of an interesting result that offers some wiggle room for other things to happen that could be good. Now, here's a really interesting QSO happened back in 2001 around solar max of cycle 23. It was Easter Island to VU. That was on 6 meters. At 15:30 UTC, it began. It's about 2 hours after CE0Y sunrise, and about 2.5 hours after VU sunset. That's right. The best estimate at the MUF suggests a skewed path that stayed nearer the equatorial ionosphere on the long path. So it's hard to say what really happened, but that's just a hypothesis, and maybe that's what really happened. But there can be some pretty interesting 6-meter paths. You got to be in the right place at the right time and probably have some good, a good setup too. And here's a bunch of those K6MIO documents. You can look at those. He also teamed with Gene Zimmerman on some of them, but most of these were these were all at the Central States VHF Society. So again, those are very interesting reading. So it looks like cycle 25 is going to be bigger than cycle 24 right now. That's what it looks like. How much bigger? Well, hopefully in 6 to 12 months, we'll know where it's headed. And again, I'll remind that cycle 22 had 6-meter F2. So we should expect it for cycle 25 in the fall and winter months around solar maximum. We've already had some. Again, the east-west propagation will be the toughest, but I suspect we'll get there eventually. And if cycle 24 is bigger than cycle 25 and maybe approaches cycle 23, well, that kind of says that, yeah, things are going to be pretty good. And a lot of people are going to take advantage of the 6-meter band switch on their rigs. Now, the F2 region is very dynamic. We have to understand that. We don't fully understand what causes all that. So don't rule out short-term enhancements due to solar flares or CMEs, coronal mass ejections, or other events. Things happen up there that we just don't fully understand. And of course, to see what's going on, monitor Packet Cluster or dxmaps.com, PSK Reporter, WhisperNet, or anything else you can to determine what's going on. And if you want to try and understand if it's a sporadic E contact or F2, you can look at probabilities and take a pretty educated guess at what it is. A lot of interesting stuff coming up. Hopefully we'll have some good sporadic E this weekend. And hope to, like I said, I hope to work a lot of you guys there. So that's all I had, Paul. If there are any questions, I can try and answer them. I know I didn't cover everything, that's for sure, and never planned to. Wanted to just focus on the F2 region.
Well, that was great. That was great, Carl. Really, really informative. And sure is a lot of, it raises more questions, I think, now that you've these things up.
Yep.
Like today was a very strange day for 6 meters, at least from my perspective, because normally we expect if there are going to be any enhancements, it usually happens around 10, 11 o'clock local time. And
Paul, Paul, could you hold on? I got to let the cat out real quick, and just so his last night, his last going out for the day. Hold on, I'll be right back.
Okay.
Okay.
That was faster than I thought.
Funny, an unusual day today, right?
Yeah, unusual days. So Dana, VE3DS in Toronto, said that this morning he was hearing the UK coming in very early in the morning, like around 7, and it faded out around 8:30 this morning. And then around 7:30 this morning, I just happened to be working out in the gym and looked at the band with my phone, and sure enough, the Europeans were piling in like I'd never heard of it before, and I was working with like 80 watts, and again everything started to fade out towards like 8:30 in the morning. So this is like counterclockwise or counterintuitive, but I'm thinking when the sun comes up, it starts to enhance the ionization. And something happened today that made it more likely to have that happening. And then followed this afternoon by a late afternoon opening into Japan. And it was very, very strong into here, but also down in the Caribbean. So, I look at the MUF is only like, or not the MUF, but the solar flux is only 100 today. So I said, okay, this is different. I would expect it to be like something else is going on. I just couldn't explain it.
Yeah, well, many people have tried to correlate propagation to solar flux or sunspot number, and you just can't do it in the short term. Like I said, there's stuff missing. For example, I was at CPAC this last weekend, and I was talking about the things that make the F2 region vary. And I looked back at the Mount St. Helens, which erupted May 18th in 1980. And right around, within about 1,000 miles of Mount St. Helens, the ionosphere took on a sinusoidal type variation of pretty large amplitudes. So, there's stuff that affects the F2 region besides solar flux and even geomagnetic activity. And we just don't understand it good enough. So be cautious if you're trying to correlate solar flux with what's going on. It kind of works in the long term. If the solar flux is 200 for a long term, then it's going to be better than if the solar flux was 100 for a long term. But when you get to the short term, just be aware that there's stuff going on we don't understand.
Anything can happen.
Yeah. And I think FT8 is showing that.
And then,
more there than we realize.
Bill WT0DX and myself, we operate multi-op during the FT8 or the digital ARL DX contest this last weekend. Mm-hmm. And I was amazed at the propagation on 15 meters. It seemed to be almost continuous across the whole contest. But the funniest thing was I was working like VUs in India, and I was working Europeans, and I was also working JAs and BKs all within a few minutes of each other. So it'll be interesting to see what the logs that were submitted will show in terms of what the propagation was like throughout the contest. It's just been amazing. 10 meters is a must, but 40 meters was wide open very early in the morning, and so was 20 meters. So it was a very different weekend for us.
Yep. A lot of interesting stuff going on.
Any other questions, guys? Surely you must have some questions for Carl.
I'd just like to say I was quite impressed with the detective sleuthery figuring out that was it 1957 300 QSO thing. That's neat, forensic CSI stuff. I like that.
It's a lot of work with, it probably be automated on a PC, I bet, but it was all manual. But it was interesting, and I looked at like sporadic E openings in the summer between the East Coast and West Coast, and it's a bimodal. In other words, there's two peaks of probability, and it's pretty interesting when you dig down into it. Again, our understanding is all probabilistic, and we can just say that, well, this is more likely than that, and kind of leave it at that.
Lots to learn, eh?
Yeah.
And thank you, Carl. Great presentation.
Yeah. It seems the more you learn, the more you realize you don't know.
Any other comments or questions for Carl? Okay, well, if no one else has anything, thanks again for
You're welcome.
for being a great presenter for us. This is the
Okay.
second time Carl has done this for us.
Yep.
And we always welcome you to come back anytime, Carl, and hopefully you'll jump into one of our Zoom meetings.
Yeah, I usually try and listen. I was chatting with Frank W3LPL via email today, and
Yeah.
he said he wasn't going to be here because he was going to dinner with his wife Phyllis. And man, what? He chose his wife over me? Come on now.
I mean, sometimes you have to know where you stand.
That's right. Yeah, no kidding. Yeah, I understand what he said.
Bill and I have been doing some experiments with, I have a 5-element M² antenna, and we put it at about 50 feet. And then he's got a 7-element M² at about 100 and maybe 10 or 120 feet. Bill, you still on there? Oh, you could just let me know.
Yeah, it's at 90 feet.
90 feet, okay. And we're kind of noticing the differences in the two patterns, because I think we're seeing a lot of faster QSB, and that might be because of the angles of radiation that we've got, like multiple little loops coming up there, and they're hitting at different times. Whereas the one that's at 50 feet seems to be a little bit steadier. And Bill, didn't you have a comment today about like the difference between the 5-element and the 7-element?
Yeah, I've used the 7-element for a few years, and it works at 90 feet, works very well domestically. But I've always felt it was a little lackluster when it came to European openings. So we took the 5-element beam and side mounted it on the tower and just pointed it at Europe. And today was the first European opening for us here in Denver, and not scientific, but my impression was it was working better into Europe at 50 feet, 5 elements, than the 7-element at 90 feet, which I think is what's predicted by folks that understand all the trigonometry involved in things.
Yeah, because when you put the antenna up higher too, you're going to have more kind of nulls in the pattern. And if the elevation angle happens to fall into one of those nulls.
Yeah. Well,
I found that to be the case on the 77-foot high LFA compared to a 40-foot 7-element I have now. In the 40-foot 7-element has run circles around the higher one, especially to the Caribbean, but for the long haul to Europe and to Middle East and to JA, I've had much better luck with a 40-foot antenna, 40-foot high antenna than the 77. I'm planning to add a second one, and the heights will be like 50 and 77 with a stack match. So I'll be able to pick the vertical angles and try to optimize it. And hopefully that'll go in before the season is over. Not Frank, but Terry W8ZN, my son Andy K9LA, hopefully after the VHF contest to put the antennas at the 2 new heights and then add the stack match. So, but definitely the 40 meter, if you're going to go with an antenna, go between 40 and 50. Frank LPL says 50 is optimum. He has his 11-element 6 meter beam at 50 feet, and it's a killer height. And he compares that to his 100+ one, and the 100+ one doesn't very well. Now, when F2 starts, that's where we'll benefit by the higher one with the much lower angle.
Yeah, that's
incoming angle.
Yeah, the lower the angle, the lower the angle of incident on the ionosphere, which means the higher the MUF, which certainly helps. 50
Carl, if you're talking, I don't hear any audio.
I'm hearing it.
Yeah, we're hearing it.
Yeah.
Carl, you're fine.
Yeah,
Not
okay.
any audio at all.
Oh. Hey, okay, Jim, 6am MIO. Is there a place on the web that
There you go.
you can find your documents, or just Google the ones that on that slide number 39?
Sorry, try that again.
Okay, for those documents, your documents I listed on slide 39, can you Google K6MIO and people will find them easy or what?
Actually, I'd like to take a look at that myself. One of the good and bad things of moving back home, actually, home in the fact that this is where all our children are, or almost all of them are. I got my PhD at the University of Florida. Of course, I grew up in Fresno, and I moved back here about 4 years ago, and we're still just trying to get things going here. I mean, the things we'd like to do, like put up the antennas, they're all out there, and they're all on the ground at the time. To get back to your question, I will take a look at what I do have. What is also true is that for quite some time, I've been looking at, for a long time, the solar data on a quarterly business, but the fact is that I could as easily capture that same information on a more frequent basis. That if there's a way to pass that through to the club to access it.
That'd be awesome, Jim.
So speaking of strange conditions on 6 meters, I've been on 6 meters the whole time here. And I was just trying to work a new grid in Idaho, for a new grid for me in Idaho. And I completed a contact with a JA station instead.
Yeah, there's a
Darn.
I really wanted that new grid. I've
Of
done
course,
Japan
of
before.
course.
And just tell the Jays to cut it out.
in the
Oh,
In
looks
the
like I'm getting the new. Looks like I'm getting the new grid right now. So thank you, FT8.
In the chat, there's something from Barry. It says, about a month ago, I worked into southern Brazil from Vancouver with 10 watts and buddy pole. And he asked if that was what that was. And more than likely, it was some kind of link to transequatorial propagation. So
Sure.
what was it, F2? I'd probably go with sporadic E maybe, but who knows? The sporadic E link into the transequatorial propagation.
It was only a few weeks ago. I was working CE and LUs on 6, again with 20 watts, or sorry, 80 watts, and that was kind of again very late in the season for me. I normally get those guys in the winter, but for some reason it was coming in May. So again, very strange conditions these last couple of months.
Yep. Well, it's like the whole, a lot of people comment that 160 was not as good as it should have been during this last solar minimum. I don't know, maybe something's changing in the Earth's environment or something.
Maybe the magnetic poles are switching.
Yeah, I wouldn't doubt it. Yeah, well, it's going to happen, I'm sure.
Everything is going on, that's for sure. Somewhere.
Yeah, it's probably Putin's fault, whatever it is. Shoot.
Of course it is. And the price of gas.
Yeah, right.
All right, guys. Thanks very much again, Jim and Carl, for
Sure.
giving us your expertise tonight. Oh, Joe, you got a question? You're going to need to unmute yourself. Just hit your space bar. Just hold your space bar down. There you go. Oh, You gotta hold it down. Hold, just,
No,
No good.
you gotta press the space
Oh,
bar.
I have-
yeah, there you go.
I have to hold it. I just wanted to say thanks for the great presentation, and we'll see you next time.
Thank you, Joe.
Thanks, Carl.
Steve,
I got in
Okay.
so late. Go ahead.
go
I
ahead,
got in
Steve.
so late. Is there a way to find a copy of this whole presentation so I can get back to it another time?
Absolutely. It's gonna be, I've been recording it and it will be on YouTube. Just look up the Front Range 6-meter group on YouTube.
Got it.
All our
Okay.
all our recordings are there.
Yeah, okay. Sorry I was
And
late.
if you go to the webpage for the Front Range 6-meter group, there's a files section. And in there, I will put Carl's presentation and puts it in a PDF so that you can actually see the actual slides.
Great. Okay, thank you.
Any other questions or comments?
Thank you, Carol. Good night, guys.
Paul, you
Okay.
better get,
And the contest this weekend.
Paul, you better get your 80 watts, better get your 80 watts on right now, because I'm
Yeah,
working pan again.
Oh, okay. I'll see you guys
Thanks,
later.
Carl.
All right, bye-bye.
Bye-bye.
Thanks,
Bye.
Carl. I'll be selling EN29 on Saturday, guys, if you need it
Okay.
for free.